With the second wave of COVID-19 hitting the US as hard as ever, I'm sure we're all wondering, what's next? But what if we could use machine learning to analyze COVID data to reveal trends and patterns and predict the next coronavirus hotspot? This is Big Data Analytics. Big data deviates from standard data analytics with three V's: volume, velocity, and variety. The amount of data processed, or the volume, is so immense that it must be analyzed computationally. Another factor defining big data analytics is the rate at which this data is being generated, or the velocity. Lastly, data comes in a variety of forms, making it increasingly difficult to analyze without the use of computing power. In order to optimize the analysis process, machine learning algorithms can be trained to identify trends and patterns. So now how can we use big data and machine learning to track the coronavirus spread? Currently, COVID-19 is exploding across the US and forming hotspots in states such as Florida, Texas, and California. But what if we were able to get ahead of the virus, predict future hotspots, and take extra precautions in these areas? Well, that might be possible with the use of big data analytics. So my friend Prineet and I started working on building a model to analyze COVID data and accurately predict the next hotspot in the US. Well, actually, he kind of built it. I was just there for moral support. Are you done yet?
All right, so Prineet, why are we using like big data and machine learning?
Well, it's the future, the future's today, and it's just the best way to predict what's going to happen in the future, and that's with ML.
All right, so basically, can you give me like an overview on how this model works?
There's two parts to it. The first thing is a cost function, which is linear regression in this case, because we have to pass in numbers to get a number back. These numbers that we pass in are called features. They can be in the form of density in a state, how each state has been affected by riots. They can be temperature, and that gets passed into that. And there's a second part called gradient descent. And gradient descent is used to pick two values of a variable called theta to adjust to our numbers to bring a real result. So the gradient descent is used to find that theta value.
Praneet's going to be making a full in-depth video on his channel, so I'll link his channel in the description. Go subscribe. How can this like possibly be used in the future, or right now actually?
Right now, the way it works is I was training this model using data from states. So I copied and pasted some miscellaneous data. So the population density, the temperature, if their state voted Democratic or Republican during their election, and a scale on a 0 to 5 scale a 1 to 5 scale on how badly the riots have affected them. And so I used those numbers and then I ran gradient descent on those numbers. You would pass in city data instead of state data. So I passed in the data of 50 states to train the model, and then now if you want to get out a result, you just pass in the population density, temperature, Democratic or Republican mayor, and the riot scale.
So basically, let's say we have a set of data points on this graph. The cost function is going to use linear regression to make a prediction for the line of best fit. We want the slope of the line of best fit to extrapolate the points and predict future outcomes. Then, the cost function evaluates how wrong the prediction is. Lastly, it uses gradient descent to improve the algorithm and make it more accurate. In reality, there are a bunch of different parameters we're passing in, and a bunch of features to analyze. It's difficult to perceive all of these relationships and find patterns in all of them without the use of machine learning.
This was written in Octave and C++ Fusion. I used Octave to write, train, and test the model, and I used C++ to create my data set. So how this works, if I were to use it, I would click on this pass in text document, and I would pass in the data of a city that I want to test. So what each number means, I'll go over that more in my video, but you would just pass in the data that you're testing for, save it, and then go to the model, run, save file and run, and the estimated number of new COVID-19 cases before it goes away is 41,281. So that means we expect that many new cases before the virus hopefully goes away. So I tested it using old data with the new outbreak, and that worked. So this is, I'd say it's a pretty accurate model.
All right, that's the end of the video. Again, one more time, shout out to Prineet for this. That he was the brains behind this project. I kind of just made the video. So anyway, I'm going to be linking his channel down below in the description. And yeah, thanks for watching.